Hello.
Hang on. Load.
Now we're recording.
There we go. Now we're on. Game on. Let's go.
Good morning, everyone. So today we are going to be talking about the planets and their relative distance away from both each other as well as the sun and their sizing. So first of all, I'd like to ask anyone, has anyone talked about planets in previous education, so primary or secondary? Did anyone do science or what do we remember from our science education?
I remember learning the name and the order of the solar system, of the planets, but I don't remember exploring that any further than just the names and the order. And then looking at what Earth does in space, but not really the other planets.
I'm the same. I haven't explored that subject in a very long time, like maybe in secondary school, but not that I can remember much about it. But yeah.
No, I don't remember too much. I remember talking about a lot about Mars and the moon, and then I think Venus, just so like the two planets closest to us, but I don't remember talking about anything like further, like Jupiter, Neptune, or Uranus, or anything like that. Mainly the moon, like talking about like the waxing and waning of the moon and stuff like that.
Yeah, that was a really big thing. I remember looking at the planets like solar system style, and then looking at some of the theory back when I was in like year 9, looking at some like theories like Ptolemaic, heliocentric, all those different theories about how the solar system actually works. If that makes sense.
Yeah.
But outside of that, yeah, no real looking outside of Earth and Moon, and yeah.
Yeah, fair enough.
I remember the Pluto debate.
Yeah.
I think I was in grade 7 when Pluto got demoted.
Yeah, I remember that.
I think Pluto was 2006. It got revoked. Yes. Okay, awesome. So I've moved one of the activities further down just with the mnemonic because I thought it would be better to have them in order for that mnemonic. But the next activity will be looking at our fruit diagrams and discussing what planet that would be based on their sizing, as well as arranging them in their correct order. So I'm just grabbing all of my fruit and objects and all that down. So I think you can see all of those now. So we've got our lime, grape, little peppercorn, 2 cherry tomatoes, apple, and then just a large ball and a pokeball to sort of represent the other planet. So does anyone want to have a stab at the dark at which one the lime would be? Based on sizing.
The lime.
Neptune?
Yeah, Neptune.
Yeah, I'm liking Neptune.
Have we got any reason for choosing Neptune?
Well, Earth would be a little bit smaller than Neptune, but Neptune's not as big as like say Saturn or Jupiter.
Yeah.
It's like looking like a nice middle ground, I think.
Nice middle ground. All right, too easy. What about the grape? What do we think the grape might be?
It's one.
Venus.
Venus, possibly.
Venus or Mars? Actually, no, not Mars.
Not Mars.
We don't talk about Mars here.
Yeah.
I'm like an idea of Venus.
Venus, yeah.
All right. The little peppercorn. I don't know if you guys can see that. Can you see that well?
Yeah.
Down there.
Maybe Mercury.
Yeah, the first planet is the smallest.
What about the first cherry tomato, the one smack bang in the middle.
Oh, easy Earth, easy Earth.
Oh, that's true.
Easier.
Yeah.
Yeah, Earth and Mars are the same, aren't they?
Yeah, something along those lines, I thought.
All right, so I forgot about my little things here. So as we continue, I'll just tape these to what they were. So we said that one was Neptune. We said the little grape was Venus. We said the peppercorn was Mercury. Oops, take that backwards.
No, we got this.
Grape, that one. You can all see that. I'm just gonna, instead of taping them, I'm just gonna move them, that way it's easy. What did we say the peppercorn was? Mercury.
Yeah.
That one, Mercury. Earth. Yeah. Mercury, Earth, and then what did we say the other cherry tomato was?
The solid.
Venus? Was
Wait.
it Venus?
Oh, I thought we already had Venus. Was it
Venus
Mars?
is the
Mars, I think.
Or Mars?
Earth and Mars were the
Earth.
same. Is that what we talked about?
I think
Yeah.
so.
Or it's a red tomato and a red planet. I see the connection.
All right, no worries. Can you guys see the wording on there, or is it backwards?
No, it's fine.
Good.
Awesome. And the apple, what do we think the apple might be?
Uranus.
Uranus. All right, that leaves Jupiter and Saturn. What do we think the larger ball would be?
I think Jupiter's the largest.
Jupiter's the largest.
Mm.
Everyone else in agreement?
Yes.
Yeah. Easy.
All right, so one is Jupiter. And then we have
Saturn.
our Saturn. All right.
Lucky.
Now that we've sort of named all of our planets, what we'll do is we'll work on arranging them in order away from the sun. So let's just make the tub the sun. If that's the sun there, what order do we think they would come in? What do we think goes first in that order? From the sun being here across that way.
Well, Mercury's first.
Mercury's first.
Yeah.
Everyone in agreement with that?
Mhm.
Yep.
All right, no worries. So let's move.
We'll move the small shriveled fella towards the sun. You know, it doesn't seem such at all.
All right. So that, yeah. So we can see Mercury. There it is.
So small.
What about what's next?
Venus.
Venus is next. All right. So Venus actually doesn't have to move very far.
Mhm.
It was already set up.
What about what's after that one?
Earth
Uh,
and Mars.
God damn it, you guys have like foiled my plan. It's pretty all right, what's after Earth?
Mars.
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 They're already chilling together. Might as well just keep them there.
Might as well. All right, what's after Mars, everyone?
Uranus.
I thought it was Jupiter.
Jupiter.
Line. I'm just going by the shape of the
The
sun.
planet.
Jupiter.
Yeah,
Jupiter.
'cause I always thought it goes from like a smallest to biggest in the middle and back down
Yeah,
to
what am I
smallest.
thinking? Yeah.
Might have to like move everything over a little bit. Running out of room. We'll just sit Jupiter, the huge lad, in there. That way we can fit everything on the screen. We'll just
Okay.
move the
He'll
sun
come back.
down. There we go. All right, after Jupiter, what do we think?
Saturn.
Saturn.
Do-do-do.
Apple out the way. Saturn squeezes in.
And Uranus.
And Uranus.
Yeah, yes.
And then are we going the solid Neptune?
I think Neptune's next.
Do
It's an elimination.
Got it.
we need to be screenshotting this, or are we using screenshots from the previous?
The failed recording.
Yeah.
We've got some in there, but I say take a big screenshot of this one because this is
I'll shuffle everything a little bit closer together. That way we can all get them in frame.
who's
Take a screenshot of Darcy's screen.
yeah. Oh, well, so hang on 2 seconds. I can screenshot.
I've got it.
Oh, you got it.
Yeah.
Perfect.
So that was our ordering there. Now we're going to look at what each planet actually is in relation to.
I'm pinning your screen, Darcy, so we know.
Pinning my screen.
I got you.
So we were actually pretty close. I'm just scrolling up towards the photo that I have.
Did we do it, guys? Did we succeed?
I'll tell you what, we were pretty close. So
That's right.
obviously in this photo there's no watermelon, it's represented as that. And there's
We made a couple of alterations due to
Right.
financial issues.
no funny. Who has a grapefruit, honestly?
Yeah.
Um,
I got the grapefruit juice, but you know.
Yeah. So this is the actual layout. So we were pretty close.
Oh, we got Venus and Mars wrong.
Yes.
Oh.
So Venus, it doesn't go from smallest to largest and then back to smallest. There's actually a little dip in the start. So Venus and Mars are
Different.
differences, but Venus is actually closer shaped to Earth than what Mars is.
Oh,
Mm.
We've rearranged that one there. And we've named all of our shapes. Does someone want to take another screenshot of the correct order now?
Got it.
Awesome. Alrighty. So now that we've looked at that, so we've renamed all of our fruit. Is there any objects that we can use to look after looking at this in relation to their sizing? So we got Mercury being the smallest and Jupiter being the largest. What do we think that we could substitute for the sun? Because obviously this is pretty small to be the sun. What objects do you think we could use to substitute the sun?
A big bouncy ball.
Like a bigger bouncy ball, like an exercise ball or something?
Or like, yeah, even like a basketball or something.
Yeah, potentially.
Yeah.
In the previous recording, because we had a failed recording just for Ali's sake,
Mhm.
Stephen
Solid.
and I mentioned a pumpkin, like a large pumpkin,
Oh, yeah.
go
Oh,
fairground.
yeah, keep the fruit. Yeah.
to keep that fruit themed. Obviously, we're not keeping that fruit theme here, but
Oh, I get you now.
yeah.
Oh, okay.
But yeah, if we were using other objects, Alana, do you have anything
Well, my thought was a bigger beach ball,
like
just
a beach?
because of the size of the sun compared to the planets to try and get that scale.
Yeah, awesome. All right, so let's try and make up. Considering I moved activity 2 or activity 1.2 down, let's try and make up a mnemonic for our ordering of the planets. So I wrote down Jupiter.
Yeah, we saw Jupiter.
Jupiter's rolling.
So I wrote down the first starting letters on a piece of paper and then I threw it away. So let's just look at the starting letters of each planet. So we've got M, V, E, M, J, S, U, N. So a mnemonic is sort of, for those of you who don't know, it's like never eat soggy Weet-Bix. It's just like a way to memorize them without having to remember all of their names. So it's just like an abbreviation or a saying that you'd say to sort of help you remember all of those. I've changed this because I wanted them in order, because if you're going to be reciting the planets, better to have them in order rather than just all jumbled up. So we have M, B, E, M, J, S, U, N. So I'll give us like a minute and we'll pause. Can we pause the recording and
Not really. No.
discuss our thinkings of what possibly use as a like an abbreviation or a mnemonic.
So do we have to come up with our own one, like specifically?
Yes.
So yesterday we had a couple of goes. Our previous recording, we had a couple of goes at this.
Do you remember?
What? Oh, can I say mine?
So I came up with my very eager mum just sat under, and then I couldn't think of an N.
Neville.
And then Stephen jumped in and said Neville.
So we thought we might change it from that.
Oh,
Yeah.
come on. Show Neville some love.
I think that makes a little bit more sense.
And
And
then we thought maybe my very eager mum just sat under Neptune, or
I like that one.
You know,
What
gotta get
about-
that planet placement in there.
yeah.
my very eager mum just stood upon Neptune. It might be easier to stand on Neptune than, even though it's a gas planet, but
Yeah.
Yeah.
I don't know.
That's CDSU coming through.
Yo, casual CDSU drop. We're out.
It was really hard in those doing those activities to try and put my brain back to what I've been looking at
Yeah,
before.
Like your prior knowledge.
Yeah, trying to
Yeah.
do that rather than going, because of the CDSU, I know where all the planets are and all of that, but trying to still be involved in that activity, and putting my brain back to a week ago before I did the assessment. But yeah, so my very eager mum just stood up on Neptune.
That's
That
a
was-
good. I like that one there.
Hmm.
Unless anyone else has any other abbreviations or ways.
I think that was pretty good what she said, yeah.
Is
Yeah.
extroverted too big of a word?
Oh my days.
Because for her to, what was it? What was the end?
Just stood upon Neptune.
Yeah, I was gonna say my very extroverted mum, because like only an extrovert would do that, not an introvert.
All the way to Neptune and then stand upon it.
Well then, on that extroverted note,
That's a good one.
I looked one up, and it's just so much more simple, because like the simpler words, the better.
Yeah.
It was like my very excellent mum just served us noodles.
Oh.
Yeah, I
oh,
was like, that's so good. But then we have to come up with our own. So
I reckon ours is on par with that.
yeah,
I
with
want noodles now.
All right, so we've had a discussion about our mnemonic. Is there any patterns that we can see in the ordering of the planets there? I'll just pan down so you guys can sort of have a look. Is there any sort of pattern that we can see with the planets?
I think just like what Stephen said earlier when we were putting them into line about how they grow, I guess get bigger. So the biggest is in the middle, and then they kind of taper down each side ish.
Do you
yeah.
reckon it helps with balancing out like the gravitational like rotations or anything like that?
Oh.
I haven't read anything about that, but like obviously we're revolving around the sun's gravitational pull. Is that correct? I didn't look at the CDSU for this.
Yeah.
Yeah.
It's heliocentrism. We rotate around the sun because the sun's gravitational force extends and is so strong that it forces us to orbit, much like the moon orbits the Earth.
Yeah, so my thought was this, and this could be completely wrong. My thought that was Jupiter sort of extends that gravitational force and like onto the other ones to keep it sort of not too close but further away. But then I realized Jupiter has like 20 moons or something like that, and they all revolve around Jupiter. So it's a bit weird. I don't know exactly how it would work, but maybe it's an alternate conception and I'm just a student learning.
That's a fantastic example of
All right, so that concludes activity 1. We looked at the sizings of each planet as well as their order in which they come from the sun. So our next activity will involve me showing you guys a video, just because I didn't have time to run downstairs, draw it out on the concrete again, and then do it again for now, just for time constraint.
I'll pin the screen, Darcy.
I think it took me like an hour to like draw that and do all that. So what I'll be doing is just showing you the video that I made, and then we're going to be filling out, or we're going to be guessing and filling out our own little diagram. I literally said I'd use the clipboard at the beginning of the recording, and I'm not using the clipboard. So we're just going to be looking at that there, and then placing on the scale where we think each planet would go in relation to the scale. So I've got your own colors there. So I'll be plotting your answers.
Oh.
Colors, man. We're moving up.
So I'll be plotting each of your answers on there, and then we can actually compare to the true form, which I've got on another piece of paper there. So
Right.
show you guys the recording, and then what we'll do is we'll continue on our journey. I mentioned in the recording that we will be pausing and answering the question. So what I might do them one by one, or I might just get you all guys to pop it in the chat. No worries, I'll show you guys the recording and then we'll get onto our guesses. Right, it's Darcy from Unknown Factors here, and today we're going to be looking at the distances of planets from the sun. So basically what we've done is I've drawn out a 30-meter area where we can see that we have our sun there, and then we have our planets represented down there. So we have our peppercorn, so that little black thing on the blue tub lid there, that is representing Mercury. We have one of our cherry tomatoes, that is representing Venus. Another cherry tomato for Earth. Mars is a grape. Couldn't find a blueberry, sorry. And then we have Jupiter, which is our supposedly warm one, but it is a bit discolored. We then have Saturn, which is our large grapefruit, which I couldn't find, obviously just discolored. And then we also have Uranus, which is the apple, and Neptune, which is our lime. So we're going to be plotting them on our 30 centimeter scaled diagram today as a group, just because couldn't have you all in my front for this experiment. So we're going to be plotting them on there, and then whilst we do the activity, I'm going to and placing them on our 30-meter scaled version as well, which goes down just to before that car there on that side there. So first of all, I'll just look at my little cheat sheet. I might ask you guys to, using the printout that I've emailed you, I'll pause the video here and we can have a discussion about what we think goes where. So I'll give you guys some time to put, people staring at me and the car's going by. I'll give you guys some time to plot where you think each planet would go. So starting with Neptune being our peppercorn there, and then moving through to Venus, Earth, and then Mars, Jupiter, Saturn, Uranus, and Neptune. I'll provide you guys with a list of each fruit and what they are represented as well. So I'll give you guys some time to do that. So I'll pause the video here, and we'll continue on with our guesses and as a discussion. Okay, so we've had our... All right, so we'll pause past me for a little bit. Obviously, things have changed a little bit. So instead of me emailing it to you, I thought it would just be easier to document all of them on the one document. I think past Darcy goes on to explain that all of these answers will be in centimeters just due to the scaling. So what do you guys think would be easier, like getting you guys to take some time and then post all of your answers one by one, or just giving you time for each planet and then you guys giving me the time so we can sort of see as we go?
I think if we do individually, we just say our answers and I can pin everybody so we're all being seen while we're doing it.
Yeah, I don't mind that.
That'll be just covers us in terms of making sure everyone's engaging and showing.
All right. Well, these answers have to be your true answers if we're going to say them one by one. Nobody take influence from other people.
I don't think I have any idea of the distance between planets though. So how am I, like, I don't know.
That's a good thing. That's
just
a good
guess.
thing.
Just guess, Maddie. Just guess.
Okay.
Yeah, me either.
Full send it.
With this though, you guys know. You
No. It's just full send it. Just full send it. Whatever you first think.
Because this is where you guys joined yesterday in our discussion. So we had like this pretty much
you
done.
asked me.
But even some of the answers that Stephen and Alana gave were miles apart, like thousands of kilometers apart. So
we watched.
Thank you. The one we got with you.
How accurate we are. It's just a means of gathering where we think we would be in relation.
We were kind of like, get smart. We missed it by that much.
Quite a bit. All right. So, Alana, starting from the sun. So the sun is the 0. Where do you think Mercury would be?
Alana, you're pinned. Game on. Let's go.
I'm going to go with 1 centimeter for Mercury.
1 centimeter. So 1 centimeter, Alana. And that was for
Mercury.
At the end, Darcy, if you want, I'll pin you back and we can show where everyone's thoughts are after we've all individually said our things.
Sounds
just so we can track it. Cool.
All right, Stephen, you're up next. On the scale.
I'm coming. Hang on.
Mercury would be.
I have to agree. It would be about the 1 centimeter marker, I think.
All right. Madeline, you're up next.
Well, I'm gonna be maybe like 1.3 or 1.5 centimeters.
Oh man, you fancy. Chuck in one of them decimal points.
Just to be specific. Are we allowed to do?
Yes, we are.
Oh yeah, you're allowed to be as specific as you want. I'm just going to be estimating. I'm not using a ruler, so I'm just going to be like.
Yeah, that's fine.
Yeah. Maddie just comes out, whips out the decimal point 5 seconds later. Wait, can I actually do that?
Like 10 centimeter, like 10 decimal. All right, Kira, what about you? What do you think?
Wait, Maddie, what did you say? 1 point.
You did about 1.3.
Yeah, roughly.
I'll do 1.5.
1.5.
Oh,
nice, Kira.
Battle begins.
Kira's saying the price is right. She's just priced it right there. All right, so that concludes Mercury. So let's move on to Venus. Where do we think Venus will sit in relation, Alana? 2 centimeters.
Wow, that was quick.
Venus. All right, Stephen.
I'm gonna go 2.2. I'm gonna chuck in the decimal points like.
Nice.
He's a trendsetter.
2.2. All right, Madeline.
Yeah, 2.2 for me.
2.2 again.
Yo, let's get it.
2.2 team.
Virtual high five.
All right, Kira.
2.
2.
Yeah.
Lana.
Oh, that's right. Competitions. I see how it is. Maddie, are we teaming up?
100%. Okay.
Okay. Next on the scale is our Earth. So where do we think Earth sits in relation to that scale diagram?
3, please.
3.
Say 3 too.
So Maddie,
Just immediately, it's all threes.
is everyone saying
I
3?
know what the scale of Earth is.
She's come to the good side.
I do know Earth.
We have cookies. Better cookies over here.
Hey, I'm a mum. I have pretty good cookies.
What cookies now?
How did we get on the topic of cookies?
Sorry, my bad.
I'm confused.
I'm hungry. I'm hungry. I haven't had anything for breakfast yet. I have a coffee, but I don't have any cookies to go with it. So you know.
Stephen, what was your answer?
I'm rolling with 3. I'll stick with 3.
I'm thinking 3.
The mum cookies work every time.
I like ginger nut biscuits, honestly. The Arnott's.
Oh.
Pretty good.
Yeah, they're good. They're so good.
So good. With a cup of tea.
Yeah.
That's one thing you could do with this activity other than fruit is you could do like little lollies.
Yeah.
Yeah.
No, red day. No.
It would probably be too hard for kids.
One would be, but you know, do you know what I mean?
Kira, where did you think yours was? I'll write all of the answers in like a table form as well. That way it's not looking like a dog's breakfast.
Yeah, I'm gonna go with 3 too. No, I believe Earth is 3.
One of us. One of us. One of us.
All right, after Earth is Mars. Remember, guys, we've got this whole scale here. We've still
Yeah,
got
I thought you were doing it like everyone says what it was in one go, and then we moved on. But you know, we kind of.
Well, I mean, I wanted to see the progress because if you go one by one, then everyone's gonna like Price is Right and try and go up or down on.
I mean, that's already happened in from Venus onwards.
Yeah, I guess. So, Alana, where do you think Mars is?
I'm gonna do 5.
5.
Oh no, hang on, no. I
Oh,
changed my answer. Because I don't think Mars is that far away if there's a robot on Mars at the moment. So
Granted, it took like 2 years to get there.
Did it?
whose turn is it? Mine.
yes.
It is a competition, huh?
Let's do 4.
Yeah, winner gets a prize.
I've got buzzers.
Wait, we got buzzers?
We should have done buzzers. Yeah.
What do you think your answer is?
What do you say for Earth? Earth was 3. I'm gonna go 4.5.
4.5.
Price is Right. Let's go.
Gone higher.
I feel like you should change the order of people who answer,
Each time. Oh, so you're not swayed. All right.
just so there's no pattern.
When it's literally like someone finally makes the comment, yeah, I'm gonna Price is Right this. Let's change the pattern. Let's change it. Let's go.
I'm doing it for consistency. Kira.
Wow.
3 point. No, wait. I said 3, didn't I? 4.
Or
Just 4. Just classic 4.
just 4.
Nothing more.
4.5 as well.
4.5 as well.
Yes, 4.5 squad.
Wait, are you doing it as well, Darcy, or is it you just conducting the?
I'm just conducting it because I have a sheet where I know.
He knows that.
Yeah. He's got the cheat sheet.
Maddie.
If I looked at it, that would be cheating if I went and did it. But no, I'll discuss the answers after we finish watching the video. So let's go, Stephen. What do you reckon?
I'm going. What's this one for? This is for good old
for Jupiter now.
Jupiter.
The largest of the planets.
You know what? I'm gonna go a solid 8.5. You know, just to give a bit of. Because I think Jupiter's a bit out there. He's a bit of a bit of a loose cannon.
All right. Maddie, what do you reckon?
Wait, can I see the scale, please?
You may.
Well, I'll pin Darcy. Hang on, 2 seconds. Wait, can you see him, Maddie?
Huh? Yeah.
Oh, okay, cool. Just pin Maddie. Got it. Take your 8.
8.
Yeah, 8.
All right.
Challenge accepted.
Wait, do you guys know all the answers?
I know most of them. They probably have forgotten all the answers by now.
Are you insulting my memory, good sir?
I've just put my brain back to prior to that recording.
Yeah.
All right. Kira, what do you think?
10.
10.
Yes.
10 as well.
10 as
Oh.
well. All right.
10.
Can I change my answer?
No.
Oh,
I was going to say that's part of the next question. So if you want to change your answers after everyone's had a guess and had a look at it, then you can change your answers.
When it's like everyone else is going that, can I just do it, please?
I'll use a different colored pen though. Oh no, I'll just use it on the bottom of the scale. That way you can see where your first answers were and then where your second answers are. Kira, where do you think Saturn would lie on this scale here?
13.
13.
I'm jumping numbers.
Let's go. Go big or go home.
Yeah. We're getting more far out from the beginning there. Let's go with Stephen.
Sarah just drinking a coffee. What was my first one answer? I'm green, aren't I?
Yes, you're green.
8.5. Yeah. Let's go 17.5.
For Saturn.
Yeah.
Whoa.
He's jumped heaps.
He's really jumped.
I feel like there's a growing distance between Jupiter and Saturn. Then they're not on the best of terms.
Okay.
Oh,
Alana.
I want to change my answer now.
No, you can change it
I
up.
forgot how big Jupiter was.
Can I do? I do 15.
15.
Yes.
Final answer.
Well, yeah.
Obviously, it's the final answer. No, I'm kidding. I'm sorry.
Wait, did I say Maddie or Alana for that?
Yeah.
oh, you said Alana for that one.
All right, cool.
And I'm going to say 19.
You're gonna. Oh.
Yeah.
All right, usurper. Let's see how it is.
Maddie said
I'm
19.
probably totally wrong.
5 minutes later. Oh, I was right on the money.
It's looking pretty good now. Like everyone's scaled out and they've gone a bit further out. So coming into the last one, Alana, do you want to kick us off?
I'm going to do.
Oh, the second last one. Sorry, we've still got. So this is Uranus, and then we have that's the 30 centimeter mark. I may have forgot to mention that this is the last one
Yeah, that's fine.
because Neptune is the 30 mark. So we got the sun down there. I forgot to write the sun there, and I forgot to write Neptune. So this is the last planet now.
I'm going to do 22 for Uranus, please.
22 for Uranus.
Dun, dun, dun.
All right,
One with that 22.
Maddie,
23.
23.
Mm.
One with that 22.
This is exciting. I think this would be so fun for kids.
Kira, I mean, it might
Okay.
it might take forever for a class of 25, but
But
Yeah,
isn't
let's do
it
that.
they would be doing post-its?
Works.
hey,
Wouldn't this where they would be doing post-its on the ground?
yeah, I'd say they would just write their answers on an individual post-it and then go and put it where they think it is.
Wait, have I done Satan yet?
Satan.
Jason.
Saturn.
Kira, is there something you want to tell us?
I was like, ooh,
Like, immediately.
Satan. Austin, imagine saying that in class.
These planets are doing my head in.
I mean, it's recorded. It's recorded,
Yeah,
Maddie.
but
So
this
we all
is-
know now.
This
Yeah.
is Uranus, so you've done Saturn. Saturn was up there somewhere. I think you did 13 for Saturn.
Okay, so 13. I'll go 18.
18. So that's where your Uranus is going to be. 18. There's some overlapping answers now.
Kira just in the corner crying.
That's good though. That's good. Who are we missing? We are missing Stephen. You're the final one.
Where am I? Where am I currently sitting? Which one?
You were at 17 for Saturn.
17. All right, I'm gonna go. You know what? I'm gonna go 25.
25.
Keep the odd numbers going.
Odd numbers. All right. Well, that concludes. Let's have a look at our final scaling, and then we'll continue watching the video on the full scale.
We done Neptune.
So Neptune is the 30. The 30.
Oh, awesome. Yeah, sorry.
I'll mark where Neptune is, and then we'll take a screenshot of that. Oh, I forgot an E.
This is where we need elevator music or something, you know? Just when Darcy's writing down stuff, just keep us vibing.
Are you saying I take forever to write?
No, I'm just saying it's nice. Like watching you write, we should have some music to it.
All right, so if you want to take a screenshot of that.
Oh, yeah.
Got it.
Oh, you got it.
Yep.
Awesome. Is that perfectly framed? Is it amazing? Is it?
Yeah, it looks gorgeous.
Incredible.
All right, so that was a good activity. I think we all did really well on that. We're all pretty much everywhere in the universe.
Aww.
What I'm
It's
going to
really superb.
So I'm just gonna play that one now, and you guys can watch. Place those. I might ask just before we move on to actually with the results and placing our planets on this 30-meter scaled version of our universe. Our system. What I'll ask is if anyone wants to make any changes, or is there any discussions as to why we think certain planets are situated where they are exactly. All right, so we'll come to that point in the video. Would anyone make changes to their guesses up here?
Oh.
Well,
No.
I'm blue.
Whoa, mate, it's really close to the screen.
Oh, sorry.
Maddie, your face is so close there.
I reckon Uranus isn't as, what color am I again? Blue.
Blue.
I would say like 20.
Maybe if I do that.
Yeah, that's better. I'd say 20 for Uranus for me.
Yeah, so you'd want to come, is it back or forward?
Yeah, I think I'm too close.
You're too close to the end. So that would put your Saturn.
Yes,
Right.
and I'd move my Saturn backwards too.
How
Wait.
far do you want to go?
Again? Where did I say Saturn?
Name of chest.
So your Saturn's at 19, and then your next planet, Jupiter, is at 8.
Okay, so I'd put Saturn in the middle somewhere.
In the middle somewhere, so like
Yeah,
14, 15.
If Uranus is at 20.
Uranus is at 23.
Yeah, but if I was to change it to 20.
Oh, okay, yeah.
And then
Yeah, it would be about 14, 13.
what was the other one before Saturn?
Jupiter. Jupiter's at 8.
Yeah, so maybe like 12.
12? Final answer?
Yeah.
Well,
Set it in. Lock it in.
so you've moved
Are
your
you
Saturn
sure?
to 12 and your Uranus to 20.
We've moved game shows now.
Yeah. Can I be the charismatic host? Darcy's the drawer / prize.
All right, Stephen, considering you want to be the host, you can tell me where you would like to make changes.
I'm actually fairly happy with my guesses.
No.
I mean, what am I? I'm green, aren't I?
Yes.
No, I'm liking where I am. I might, just for the sake of brevity, I might move Jupiter up to 9.
Jupiter
just to,
9.
Yeah, just keep it real.
So you're gonna move Jupiter half a centimeter.
Yeah, I'm gonna be that. I'm gonna be that host.
Alrighty. All right, Alana.
I don't want to change mine. I'm happy with mine.
Yours? You're happy with yours?
Yeah.
Just confident.
Yeah.
Definitely need to change mine.
Oh yeah.
Where would you like
to go, Kira?
So, sorry, I need the clipboard up again. I'm visual.
It is up.
Hang on. I pinned Darcy.
Maybe
I pinned Darcy. Hang on. I'll pin Darcy. Darcy, you are now pinned.
I'm pinned.
It's back.
See, when you pin stuff, it does nothing to my screen. I can just pin it all the time.
Really?
Yeah, it's just your screen you're playing with, so it's not helpful at all. Thank you.
Oh, not bad.
Maybe if I just make like a loud noise, you guys can see it. So if I just go la la la.
There we go. Okay, that's perfect.
But I can see your song.
Yeah.
Oh, because I always thought if you pinned someone's screen, that was for everyone. Oh, okay. Well, since I'm doing some of the recording, I guess. Unless, oh wait, does it just cycle through everyone?
Mate, no, I think it just goes to who's speaking at the time. Like same with Zoom. So can everyone see me now that I'm talking?
Okay, you stay there. Sorry.
It does not change.
Jupiter, I did 10. So I want.
Tell us what you want, what you really, really want. Sorry, I have to. Sorry.
I want Saturn over 23.
Saturn over 23.
I'm orange.
Yes. So that would make your Uranus at 18. Where would you like to move your Uranus? So that means you've got from. I know it's.
Come on, we're in uni.
I'll move the planet. I'll move Uranus planet to. Okay.
If you're moving Saturn to 23.
Okay. Oh no, it's changed again. Step in space.
Competition's a strong one. In the commentary box we have.
Oh, the board's not up. It keeps changing. It's not saying that.
Can you see the screen now? If I talk, can you see the screen?
If we're not talking, we should mute our mics. I'm going to do that now.
Okay.
Change it again.
All right. So can you see the screen now?
Okay. Yeah. So Jupiter is 10 for me. And Saturn, I want that on 18.
Saturn.
And then I want that on 18 actually, Saturn on 18, and I want Uranus on 23.
So Saturn on 18, Uranus on 23.
Yes.
Happy with that final answer?
Mhm.
Alrighty. So we've made some changes. Everyone can unmute the mics now. Why did we make those changes? Why do we think? Was it because you could see everyone else's answers and you were sort of like
peer pressure?
Or was it something to do with the relation of the sizes of the planets and stuff like that?
Yeah, relation to the size.
They need to
Mine was.
Some of them need to be spaced out, while others don't because they're small.
Yeah.
Yeah.
I agree with that.
I kept mine the same because I know that there's a group that are close together at the start and then they get really further away.
Yeah.
All of a sudden.
I think
You guys some more time.
all right. So back to past Darcy. We'll have a look at the answers on our large scale. Alana, I know you said you were on the road, but realistically, there was no other place that I could do it.
And then we'll go into the results as to why we think those planets are in those certain areas. Just a side note as well.
All right, I'll skip through that. That was just me saying.
Results are
That was just me saying that we were going to be doing it in centimeters for our answers.
we have a finished diagram here in which I placed all of my accurate results into another version of that table there. So I'll place that down here. So as we can see, first of all, we're using the astronomical unit, which is a unit of measurement equal to 149.6 million kilometers, average distance from the center of each planet to the center of the sun. So there on our scaled one, we have a line going to the center of the sun. I'm pretty sure this is just relevant to the Earth. So we'll be looking at that as well. So the first planet that we have is Mercury, and that is roughly 0.38 centimeters on our scale diagram, and then on our even larger scale diagram, we have that one will be at 38 centimeters on our large scale on there. So we will measure that out in a second, and I'll do all of those individually and show you the process of me actually measuring them out as well. Next we have Venus, which is 72 centimeters away from that center of the sun, or in this case, I will be going from the edge of the sun just because 72 centimeters from a meter will be touching the sun. So I'd say that would be the case. Next up is Earth. Earth is 1 centimeter on the scale, but will be 1 meter on the actual thing. So it'll be roughly about there from that edge of the sun there. Following is Mars with 1.52, and then Jupiter with 5.2. So that'll be 5 meters away using that scale. And then Saturn 7 meters away. Uranus 19.52 meters away, and then Neptune being all the way down the end there next to that car, so 30 centimeters away. Again, just reiterating, this is a scaled version. Unfortunately, I could not get you all here to place in your own post-it notes. So what I'll be doing is getting you guys to show me your results on the live stream that we do later on. Okay, no worries. I'm going to start plotting these areas here, showing you guys where each one is exactly situated. University, okay, so first up we have from 38 centimeters away from the sun, we have Mercury, which is the tetragrain. So that one will be sitting right there at 38 centimeters away. So now we're moving on to Venus. Hi everyone, it's Darcy from...
So I accidentally I accidentally stopped the recording there, but I continued on in another recording, so that's why I'm doing the changeover now.
So next on our scaled diagram of the planetary solar system is our cherry tomato, which is representing Venus. Bit of a shame putting these on the concrete, but we can wash these after. So that is at 72 centimeters away from the sun there. So next on our scale is Earth, which is represented as another cherry tomato. So that is a meter away from the sun. So we're going to place that one just there. So we have our peppercorn, Venus, and Earth already. So we're next moving on to Mars, represented as a grape. So as mentioned before, up next from the sun is Mars, which was supposed to be represented as a blueberry, but I don't
Mercury. So a grape is the next closest thing in scale. So that is at 152 on our scale. So we have the peppercorn there, which miraculously hasn't blown away. Venus, Earth, and then our Mars. So next on our list is Jupiter, which is represented as a basketball. That is at 5.2 meters away from our other ones over there. So we have, I don't know if you can see it, should have our peppercorn down there. Yes, you can, just that little speck. And then our two, the Venus and Earth, and then finally Mars. So Jupiter is now here. I expect Jupiter to roll away, so I might just put Jupiter in the gutter, but you still get a representation of where he is in comparison to the other planets. Maybe he's just doing a bit of a rotation there.
Oh, yeah. I like that one.
At 5.2 meters. So now, because I only have a 8-meter tape measure, I'm at the 8 mark from the edge. There's the 8 mark from the center, and so the radius, because the diameter is 2 meters across, that area in there is 1 meter. So that's from the edge of the sun there, and then I've gone a further 1.5 meters to 9.5 meters to represent where I'm pretty sure, is it Saturn or Jupiter? Let me just go double check. So this is where Saturn would be at 9.58 on our scale here. So Saturn will set back bang. So Saturn is in relation to the other two there.
Oh my goodness.
Three tomatoes, the grape, and the peppercorn down the bottom there as well.
The distance be real.
From our 16 edge mark, there's our 16 center mark, so that's our 16 edge. We have 19.52 meters away from our scaled sun. That is going to be Uranus. So Uranus is the second largest planet in our solar system. So if we look, I've gone out 3.52 meters away from 16, so that's 19.52. And all the way down there, we can see our other planet there. So place in Uranus, and we'll move on to our final planet, Neptune. So now we're at our final mark, 30 from the center, but because we're going from the edge, so our first two planets weren't actually inside the sun, we are going from 30.1 outside edge. So that there is 30 meters from the outside edge. In that gap there is 1 meter exactly, plus an extra 10, plus an extra, 1 centimeter to represent 30.1. 30.1 would be. That there would be 30.1. And then we'll redraw that one in there. That would be 30.1 there. So what we'll do is we'll place in Neptune, and then we'll look at all of our planets. Here we'll say. So here we have it starting from our sun here. Move on to Neptune, which is the peppercorn, followed by Venus.
Keep calling it Neptune, it's Mercury.
And Mars. And then all the way out here, at the 9.52 meter mark, Jupiter. Oh, whoops, I passed it. Jupiter, Saturn, down the line. We have Uranus, and finally our Neptune there, down there at 30. So if I come back a little bit, you can see where Neptune is. Yeah.
Look at these camera angles.
Where our Neptune is. All the way down the other end there.
Wow.
Where our sun is, you can just see Earth and Venus there. the sun sort of further back a bit. Line. Is that Jupiter? Saturn. Uranus and Neptune there. Okay, so I'd like to thank you for watching this part 2 of the experiment. Hope you enjoyed demonstration. I'm sorry I couldn't get it all in one video. Come back to my notes here and show you exactly where everything is on our even further scale diagram. Yeah, so that's it. Thank you very much for watching. And we'll go back to our group discussion now. So next on our
Nice.
you guys the
I like that one.
I did try to get it all sort of in the one video, but I pressed stop instead of pause. So if you look at it, that's our he's not working with me today. That's our actual scale version. So if you want to take a screenshot of that.
The bigger version really makes it hit home how far away it is. Like
Yeah.
you can see on there,
Yeah.
you actually saw how far you had to walk to get to that next planet, especially for the last 3. That was really good.
Really puts it all in perspective.
Yeah, and you can see how that could work in the class, like for the children too, for the students.
Yeah. So that in relation to our answers, we weren't too far off. So there's your guys' answers there.
I'm glad I changed Uranus then.
And there's our answers there. So we had, so the sun's at 0, and then we had Mercury at 0.38, Venus at 0.2, and then Earth at 1. Most of you guys started at 1. So we had all of your answers for Mercury were pretty much in the 1 to 2 range. And then Earth for you guys was at the 3. So everything, so Mercury and Venus are actually before that 1 mark there in that gap. For Jupiter's actually at the 5 centimeter gap, whereas you guys had yours at the 8 to 10 centimeter gap. Saturn is at the 9.5 mark. You guys had yours at 13, the lowest being Kira, all the way up to 19, which was you, Maddie, there. But you guys did adjust. So Steve,
Yeah, I adjusted that
Even
one,
with-
didn't I?
Stephen moved his Saturn back to 12. So Stephen was the closest for.
Didn't I?
Oh no, it was Maddie. Yeah, Maddie. Sorry.
Yes, I claim credit for nothing.
Excuse me.
And then what's next? Uranus. Uranus is at the 19 mark. So Maddie, you had it spot on, and then you moved it.
Oh, what was it for? Jupiter.
Wait, what was it? Uranus. Oh no, Saturn. You had Saturn where Uranus was supposed to be. So the closest was actually Kira there. Kira with 18.
Oh, yeah.
So Kira had 18 for that one there. So she
And
moved.
what was it supposed to be?
It was supposed to be 19.
What did I change mine to?
Oh wait, hang on. No, you had
I
We've
changed
got the
mine
couple
to
on the station.
Uranus is at 18.
I changed mine to 20 or something, 20 or 19.
Oh yeah, your Uranus is at 20. Yeah, so you're pretty close there.
This really is a game show.
I'm getting confused with the colors.
Yeah, fair.
So you guys were only off by like a couple of centimeters.
That's
Which
so
one?
good.
I made an improvement.
Thousands of kilometers.
Yeah.
We'll ignore that part.
Yes.
Wow, puts it into perspective. Great job.
Let's go over our ideas. So we've had a look at the videos, we've had a look at all of that. I guess it's discussion time now. It's it's all discussions.
Let's go. Discussion.
So it says here,
Oh,
facilitator Nora. Okay, so roll 2 and 4 work together for this part. Place the correct planet at one time, starting with the planets closest to the sun. Direct. Okay, so that's all the video. I think we're on to our CDSU now.
okay.
Because I couldn't get you guys all for the video doing it. It just would have taken forever me running upstairs.
You did awesome, though, man. You did awesome.
That was really good.
Good job.
Yeah, it was really good. It would have been cool if we had like a drone. Imagine a drone.
I was thinking.
That would be awesome.
That
Who
would
has
be
a-
really good.
But yeah, let's. I guess we should move on to the CDSU, which was you, Alana, correct, or was that?
Yes.
Yeah. So, I guess we should start off with the sizings of the planets. Do you have anything there about like the sizes of the planets and why they're that
I
size?
do. I thought actually, if you wanted to, if we go through, I suggested going through one by one
Mhm.
and talking about. So I've got things like the size, the distance from the sun that you've already done, the year length, the day length, and then a little bit about the atmosphere. Because what I'm talking about is how the weather would be if you could live there or not.
Oh, okay.
Yeah. So, so I thought if we just do that one by one with each planet.
Yeah.
Yeah. So our first planet obviously is Mercury, which we had in our little.
I've
Um,
lost Mercury. Just I'm like panicking a little bit because I've lost it and I don't know where it's gone.
you've met lots of Mercury.
I might have to run back to the kitchen and grab another Mercury.
And on that technical difficulty,
I might literally have to run down to the kitchen and grab another Mercury just because like I've
Do we need them again?
Hey?
Do we need them again?
Oh, I don't know. You said I was gonna hold it up, but no, it's all good.
Fine.
I'm just gonna find a random grain of pepper in my room and just gonna be like, oh, there it is.
you know, you got to stand on it when you go to grab something. You got to stand on it, and you'll be like, "I remember you."
There you are.
I
I'm
need
looking for you.
There you are, my little friend.
yours.
All right, so I'm going to start off by saying I don't think we could live on Mercury. I'm pretty sure it's supposed to be the hottest planet, being closest to the sun.
It's not actually the hottest planet.
Yeah, so I'd say we definitely wouldn't be able to live there just because of its relation to the sun. I know Venus. Was it Venus's temperatures are a little bit closer to the sun, so maybe we could live in Venus, but I wouldn't know. So my answer for Mercury is a definite no.
Mm.
I'm a
So,
solid boy.
so Mercury, I'll tell you a little bit about Mercury. Mercury is, so it has a short year but a long day. So a day in Mercury is actually 1,408 hours, but a year is only 88 days.
Oh,
So it goes around the sun a bit faster and in a smaller orbit than we do.
Okay.
But the actual rotation of the planet itself takes quite a long time. And Mercury's, according to NASA, Mercury has a thin atmosphere, and it's composed of mostly oxygen, sodium, hydrogen, helium, and potassium. So it's actually what's the word we use instead of common misconception? Alternate.
Alternate conception.
That's one.
What's that?
But
Alternate conception?
it's not. There is another planet that gets a little bit hotter than Mercury.
Oh, okay.
Yeah, just because its atmosphere is so thin, so it doesn't actually retain a lot of the heat.
Oh,
Okay.
So it like dissipates into space.
Yeah.
It's like when there's like no cloud cover and it gets cold.
Yeah, a little bit like that. I think it's the opposite way, isn't it?
Yeah.
It's cold and then it goes away.
I think
I don't know. It's really cold at my house at the moment and there's no cloud cover. So,
yeah.
okay, so the second planet is, any other comments on Mercury?
Wasn't it named after the messenger god from Roman mythology?
It is the messenger god. Did you find it, Darcy?
I found it. It was behind Venus. It was underneath Venus, so it didn't leave the table. But when I was like adjusting my arms to like make sure they didn't fall when I was holding the phone up, it must have bumped it. Anyway,
We're going to see Venus. Did he? Fair enough.
continue.
Yeah. So I don't think it's really viable to live on Mercury. So Venus is the second planet, and it is 108.2 million kilometers from the sun. It has, sorry, I'll go back to Mercury's radius. It has a radius of 2,440 kilometers. So a radius is from the center to the outside. So Venus has a radius of 6,054 kilometers. Its year length is similar to ours-ish. It's 225 Earth days, but its day length is really, really long. So it's actually 5,832 hours. So it takes a really long time to spin itself around. And the atmosphere is, according to NASA, Venus has a thick, toxic atmosphere filled with carbon dioxide as its majority gas. So it is actually, because it has such a thick atmosphere, it's actually the hottest planet because it retains most of that heat from the sun as well. So it can get upwards of almost 500 degrees.
She be hot.
Very hot. So do you think you would be able to live on Venus?
No.
No.
Why?
Not unless we had heat shielding, because we would roast alive. And also there wouldn't be much stability if it's it's one majority of gas planet.
It's still way too close to the sun.
Yes.
Yeah.
Degrees, your blood would boil. You'd just melt.
Yeah.
Oh,
And you wouldn't be able to go with the most, because there's so little. So because the majority is the carbon dioxide and such little of anything else like oxygen. So planet number three is Earth. Earth is 149.6 million kilometers from the sun. Our radius is 6,371. We know our year length and our day length. So our year length is about 365 and our day length is about 24 hours.
Isn't it like 365 and a quarter or something like that?
Yeah.
Yeah.
And our
That's
day
good.
is just a tad under the 24 hours. Like it's like 23 hours and something. That's why the leap year comes around each year, because we build up to that extra day.
So cool.
Yeah, so our atmosphere, as we know, we can live on Earth. It's a livable planet. We live here and we grow here. So we have nitrogen and oxygen are by far the most common gases in our atmosphere. The dry air is composed up of about 78% nitrogen and 21% oxygen. So planet number, any comments about Earth? Obviously we can live here.
Livable.
Pretty
Most days.
I've got a comment at the end about some stuff, but we'll go through all the planets first. I've got a comment. Yeah. Fancy.
So planet number 4 is, of course, Mars. Mars is 227.9 million kilometers from Earth. Its radius is 3,390 kilometers, so about half the size of Earth. As we saw with our fruit, it was quite a lot smaller. The year length, it has a long year length, but a pretty same day length to us. So it's a 25-hour day, but the year length is 687 Earth days. The atmosphere in Mars is much thinner than Earth's. The red planet's atmosphere contains more than 95% carbon dioxide and much less than 1% oxygen. So what do we think about the viability of living on Mars?
It's got a pretty similar environment to Earth. I think that's why they're saying that if we were to colonize Mars, would probably be the best option first off.
Yeah, it is.
I think they just need to try and produce some more of that oxygen.
I think the plan was to try and melt, I think, the polar ice caps on Mars, just because there's a lot of water on Mars, just in the form of like huge ice caps. So they were planning on like shooting something at it or trying to melt the ice just to sort of produce more water and create like the evaporation to create the atmosphere. But that would take thousands of years, I think. I think that would take a long time. Yeah, if we were to colonate, it would be sort of the Martian style, living in those domes, in spacesuit.
Yeah, man-made oxygen.
That was good. That was a good movie.
Yeah, it was a good movie.
No, I think there would have to be a definite terraforming process, as Darcy was saying. Like either melting the caps to get the bit of water out, and then just have that natural forming, like it did with the continents and everything here, or we have to implement some sort of man-made structure, or just like a little like housing blocks, plant, move on type of situation.
Yeah, definitely. All right, next we are going to Jupiter. So Jupiter, as we know, is our biggest planet. It has a radius of 69,900 kilometers. Its year length is 12 Earth years, but day length is only 10 hours. So it turns quite quickly, but takes quite a long time to do that rotation. Jupiter's atmosphere is mostly made up of hydrogen and helium. So it's a big gaseous planet.
He's a big gas boy.
Yeah, just a big ball of gas.
Isn't hydrogen like the most unstable thing?
So what do we think about the viability of living on Jupiter, knowing that it is a gaseous planet?
I got a question. Doesn't Jupiter have like one of the red storm or something, like an electrical storm or something going around that makes it known as the red eye of Jupiter or something or other? Am I making that up?
I wouldn't know. This is the first time I'm hearing about it.
I did something like that in my research because they had like a photo of it.
Yeah,
but I don't know if it was Jupiter.
I can't remember if it was Jupiter or it was Uranus. I always thought it was Jupiter because it was a big gas planet and it had an electrical storm or something, like a charge or something going around. It looked like a massive red eye.
Yeah, no, it's one of them, but I'm not sure if it's Jupiter. We can.
Yeah, I knew it was one of the later on ones. Sorry.
Yeah.
I really busted your train of thought there.
No, that's okay. So obviously living on Jupiter is probably not a viable thing as it doesn't have a solid surface. And the atmosphere isn't a livable one. We can't really live in helium.
Oh, yeah. I can imagine.
It's too much.
Okay, planet number 6, of course, is Saturn. So Saturn is quite further away than Jupiter, as we found in our first experiment. So Saturn is actually 1.4 billion kilometers away. Its radius is a little bit smaller than Jupiter, so it's 58,232 kilometers. Its year length is quite long, so it takes 29 Earth years for it to revolve around the sun. But like Jupiter, it has a very short day, so it only takes 11 hours for it to do one spin around. So Saturn's atmosphere is made up of mostly hydrogen and helium as well. So it's also a gaseous planet. And Saturn, of course, is the one with the many rings around the outside that is made up of little rocks from space.
Space rocks.
Thoughts on Saturn?
I was going to add, I think I read somewhere that Saturn's rings were actually created from like debris from other planets that had collided. So maybe that was like a comment that I would like to make. But yeah, I read that they were also like really, really tiny like specks as well, from the size of like a piece of dust. I don't think you can have a piece of dust, like a speck of dust to like the size of like houses as well, like the bulk, like
Mm. Yeah, I
Yeah.
heard that as well.
Yeah, many thousands of them. That's specifically the words that they use. Many thousands of them.
Yeah, wow.
Fancy.
Mm.
But obviously, living on Saturn isn't something that is viable with what is going on at the moment.
How long would it take to get there?
So it is 1.4 billion kilometers away. So it took. Oh, does anyone remember how long it took that rover to get to Mars? Was it like a couple of years?
About like 3 or 4 years, I think. Oh no, 2 to 3 years.
To
Yeah,
get
and
Mars?
that was probably a fifth
like
of
double
the
that.
square. So it would be quite a long time.
Who would, yeah. Like, no one would even want to travel for 4 years just to get to another planet.
I mean, it's a gas, isn't it? Like Saturn's
Yeah.
another gas planet. So
Yeah,
there's
can't
no
do it
point
anyway.
going there.
But if it was livable, I'd rather die than travel 4 years.
Patty.
I think it would be a pretty cool sight to see.
Yeah.
But yeah. So planet number 7 is Uranus. So it is 2.8 billion kilometers away from the sun. It's a little bit smaller than the other planets, than the two previous. Sorry. So it's still huge though. So 25,362 kilometers for its radius. Its year length is 84 Earth years. So it takes 84 of our years for it to do one rotation of the sun. But again, like the other ones, it has quite a short day length. So it only takes 17 hours to spin around. And then atmosphere, I think we can also mostly hydrogen and helium with a small amount of methane and traces of water and ammonia.
Ooh.
It's the methane in Uranus that gives it its signature blue color.
Fancy.
One thing to note too is that it's very cold. So that's one thing too we need to think about when we think about living conditions is whether our bodies can sustain it. So the further, I guess, like 2 billion kilometers away from the sun.
You're not going to be getting that much heat.
No.
Sure, you're good.
Yeah, I'm trying to get. There's a few rocks in my charger point, like little tiny rocks. I'm trying to charge my laptop. I'm trying to get the rocks out of it.
Oh,
Mm.
mute your sound if you're not, because there's like noise coming through.
Wait, I was curious what that was. I was like, are we doing something wrong? Was there...
It's just coming through on the speaker. I was wondering what it was.
The scratching.
Kicking out
Yeah.
the rock. Yeah.
Yeah.
Okay, so
hits while we're doing science.
our last one is Neptune. Planet 8 is, of course, Neptune. So Neptune
Blue.
is a long way away, so over almost 4.5 billion away. Its radius is similar to, not too much smaller than Uranus, as we saw in our representation of the fruit. So it's 24,622 kilometers in radius. Its year length is really, really, really long, as we can tell by how far away it is from the sun, how long it would take to do a full oval around it. And it is 165 Earth years it takes for it to do one rotation. It's only done one since its discovery. And Neptune, I believe it was Neptune that I read, was the first planet that they thought was there before they actually discovered it. So day length is 16 hours. So like the last few, it has quite a long rotation around the sun, but to spin on its own axis is quite short, it's 16 hours. So Neptune's atmosphere is made up mostly of molecular hydrogen, atomic helium, and methane.
I can't remember. I read somewhere ages ago that Neptune was comprised of water as well, or is it a gas-based planet?
I believe it's a gas-based planet. as far as I know.
I don't know. I don't know. I don't know where water came from. It's probably thinking about something.
There is a little bit of water in Uranus.
Ah.
Yeah. So thoughts on Neptune? We do have a couple of pictures of Neptune because they did send a satellite, and they are from a little while ago, but they sent the satellite out to try and explore further beyond the solar system. So whatever that satellite was, that the name is escaping me, took some pictures on the way past, and it is one of the only planets that we can't see without some quite technological equipment. So you know how some nights we can see a few planets in the sky, and even with kind of some home telescopes we can see some more.
Yeah.
Mm.
It wasn't too long ago that I think Saturn and Jupiter were visible. I actually got out on the balcony and got the binoculars out and had a look at those, but yeah, I haven't seen or heard anything about seeing any other planets further than those two.
Yeah, Jupiter. Hang on. Neptune's a recluse. He doesn't like to be seen.
Yeah.
It's all right. So I just might tell you my final hypothesis that I had a look at doing.
Yeah.
Wait, we had an initial?
Yeah.
We didn't, but I kind of thought about what the initial would be, and then from our previous video.
Yeah.
And so the distance from the sun and the spacing between the planets were vastly greater than what the unknown factors thought prior to the experiment. We also hypothesized that Mars and Earth were most similar in size, but through the experiment, we found that Mars is much smaller in size, and it is Venus that has a very similar size to planet Earth. There are not many planets that have the ability to support life as we know and need it. This may be due to atmospheric makeup of the planet,
Got this.
the surface of the planet or that lack thereof, and the distance the planet is to our light and heat source, the sun.
I think the fact that we didn't discuss an initial hypothesis before was because I think they come about when you're trying to you're testing something, like you're trying to see a change in something, whereas we're seeing changes in our results.
Yeah.
Compared to that. So
Too easy.
What year level is this targeting to?
I think it's year 5.
Yeah. So I did a little bit of research on our 5 questions for the left-hand side. And so year 5 is when it comes up first, and that's according to the curriculum. And Ali's put that in the science notebooky thing.
Yeah.
It's good. Yeah, so year 5, and then they explore it some more in grade 10. So they look at things like the Big Bang and stuff like that. Yeah.
Cool. Can I make just my comment about the planets for a quick second? When it comes to the naming of the planets, initially it was done by the Greeks. They were the ones who initially started the astronomy and started naming planets and everything. But during the Roman takeover of Greece, they changed all the planets. So you'll notice that all the planets are actually named after Roman gods. And with each planet, it actually is meant to represent a particular aspect of that god within the belief. So with Mercury, small and quick, its orbit's one of the quickest, as I think we were saying. And Mercury was meant to be a messenger god, and he was pretty quick. Then you had Uranus, which is actually a Roman Titan or a Greek Titan. I can't remember which. He was like one of the all-father type of ones, and by having Uranus all the way at the far end, being one of the oldest planets, type of synergy situation. I always thought that was interesting.
Yeah.
And Earth was initially called Gaia in some translations and some historical texts, referring to the Earth Mother from Greek mythology, I think. Yeah, I can't. One of those, and then it was changed to the more common Earth after. I can't remember why. I think it got changed in
Gaia sounds so much cooler
Yeah.
though.
Mm.
like in a movie. Returning home.
But yeah, I thought I'd chuck that in. It was just a little bit of interesting trivia.
Yeah, no, thank you. That was
Cool.
pretty cool. I didn't know that. I didn't know any of that. I thought, because in the song that I made, I thought Uranus was the only planet named after a god, hence the lion. And I was like, I have to change that now.
Yeah.
I loved the song. It was very cool.
Oh,
I'm just popped up the right-hand side of our ISN.
Yeah.
A research question.
Mhm.
Did
Oh,
we have
we're making one. Sorry, I thought you trailed off there. I thought you had one.
so my thinking is something along the lines of something about the spacing of the planets.
So something about livability, are you saying, or respecting the planets?
Well, probably more to do with the activities that we did. So about the spacing of the planets.
Sorry, I thought you said respecting. I'm like, okay.
Respect
Okay.
planets.
We need to respect our planet, sustainability, guys.
Big word, shove it in there. Sustainability plug. You know what we're talking
Curricular
about.
priority.
So
yeah.
getting
We
Go.
can go back to that in a minute. Do we want to have a quick discussion about our left-hand side is obviously the beautiful song.
yes, we have
That-
developed a song.
How are we performing that?
Oh,
it was shocking. It was
It
it was done at 10 o'clock. Like all the recording was done at 10 o'clock, and I did it in sections. So I recorded 10 to 30 seconds each part, and then you can hear it because the chorus is just the same recording copy and pasted. I could not do it in one time.
You would not.
Don't expose yourself, man. Don't expose yourself.
I had the karaoke window open up on YouTube because I did not know the timings. The timings of Riptide are really weird. There's weird gaps everywhere. So
Yeah.
even the timing, after looking at because I changed all the syllables and the words, the timing is off in certain areas. But it was the best I could do at 10 o'clock. And I stayed up until 2:30 editing and getting.
Oh my gosh.
Well done. I hope we get chosen today. I hope you get to share that.
Well, I hope I don't.
I hope you do. I was going to volunteer. I was going to be like, we'll do it.
No.
I was gonna say,
Yeah.
just be
Ellie,
you.
Ellie will probably see that there's a video there and go, oh yeah, we'll
We'll get
This looks interesting.
yeah.
great, and then she will shred us to bits. We know it. So in terms of how does this activity link the curriculum and the Australian curriculum Queensland? So we did that.
Science.
Pardon?
Earth-space science, it links directly into that, and any sustainability and any spatial awareness type of situations, I think.
Yes. So how would we address the health and safety issues in the activity?
Well, don't do it on a road, first of all.
Yeah.
Yeah.
Do as I say, not as I do.
So
Well, the kids can do it on the playground, on the cement path.
Either
Yeah,
that,
or even in a basketball court.
Yeah.
Or
good idea.
yeah, because it's all barricaded as well. So
or even an
get
oval,
out.
They don't
Yeah.
And
have,
there's shade too in the basketball
Yeah.
court.
be indoors or outdoors.
yeah.
Yeah.
They don't necessarily
Outdoor
have to
sun
use
safety.
chalk or anything like that. They could use because they have those huge wheels with those.
Oh yeah,
Oh, yeah.
So
that would be interesting. They would like that.
Yeah.
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 So what's the kind of risk factors do we need outside of not doing it on the road? So
Allergen. Oh, sorry.
the sun, if we're outside, so sun safety,
Sunscreen,
Okay.
slip slops,
Yeah. slip
Yep.
slops, that,
Hats.
no grey.
Yeah. Are we
It's
would we be doing it with the fruit? Is that right?
Yeah.
Yeah. So allergies, just in case. I mean, not that there's usually any, but that as a precaution.
Yeah. And being safe with the fruit or the equipment. So growing
Don't
them,
use
don't eat it.
Yeah.
a weapon, you know.
I think setting expectations from the start before going into the experiment, so like in the classroom, so students know, and getting students to make them as well, getting their ideas of how they think they should be behaving and when they're carrying out the experiment.
Yeah.
Yeah, setting guidelines and class rules before entering the activity, just so students are prepared for what to do.
Because once they're outside doing it, you've lost them. You know, they're ready to go. They just want to do.
Yeah.
So yeah.
I think that's also a factor in which would we do this in a group setting, or would it be
Yeah.
will we have it as a whole class situation?
I think whole class.
Yeah.
I agree.
Just to control the environment.
I had a
That's
thought about
weird.
whether like a rotation,
Oh, okay.
just because we talked about earlier how long it took us for each of us to do our answers for all of the planets.
Yeah.
Imagine if you had a group of 25 students going through and doing that.
Mm.
Would be quite a lot, unless you just let them all go at the same time. So
Yeah.
I have an idea.
Yeah.
Oh, well, doing it as a whole class activity, but students are still kind of in a groups, and in their groups they make an executive decision of one answer. So when we're say doing the distance of the planets, they all come up like as a group of however many, 3, 4, and they've got a group name, and then they can write down like just based on one decision, yep, they all think Neptune is there. So then there's not all these answers, and it's all a bit much. That could be an idea.
Yeah.
Yeah, no, I like that.
Mm.
or even giving them that 30 centimeter one for them all to do individually, and then coming together as groups. And
Oh yeah.
Yeah.
That's
Yeah.
good.
absolutely.
Sorry guys to cut in. I've only got like 5% just because I'm trying to figure out this charger thing. So if I ever just zoom out, it's probably because of my phone, my laptop's dead. So I'm just letting you guys know that. Yeah.
No worries.
That's all good.
Yeah.
Well, we're wrapping up soon anyway.
Yeah, I guess we've got to go over the last couple of points, don't we? The the science is a human endeavor, and then
And that's all of it.
Yeah.
So,
Yeah.
looking at science as a human endeavor, what does this actually do to enhance our knowledge? Are we looking? I mean, personally, I'm looking at just awareness of our world, and then awareness of what's around us, like space and what's out there, really.
yeah. Well, I mean, it helps us gain a lot of knowledge about the universe and how we were created as well. Like as humans, like talking about evolutionary traits and how the planets were formed, and how like animals, like even like say if we're using this as like a general, or is it a cross-curricular connection or a general
Capability.
capability, just looking at like evolutionary traits of like say like the crocodiles or something like that.
Yeah, and like how the sun's important too. Like, what if there was no sun?
Yeah.
In space, like
Important to
kids
the-
need to be aware of like, why is there a sun every day? Like, provides energy for the earth and just all those solar systems, and like, yeah, it's pretty interesting. Like, imagine if there was no sun, there would be no,
We
Good
wouldn't
night.
we wouldn't be here.
there wouldn't be anything really. The planets would just be floating around in space,
Yeah.
Yeah.
crashing into each other.
Yeah, so they all have a purpose. Yeah. Oh.
I think that links nicely into the nature of science. Like it's
Yeah.
it's all connected. It's all connected, and there is, like, we orbit the sun for a reason. As Kira said, we get energy from it, we get heat from it, we get a lot of resource and stuff that actually lets us live. Like it lets plants grow, as we know with photosynthesis. So if we're looking at a link between, that's boom, immediate. Gravity.
I think you like your days and your years going out to the solar system. Why do we have a day that's 24 hours? Why is our year not just infinite wide
Yeah.
and stuff like that.
Very interesting.
Mm.
Gotta love science. Let's go, guys.
Interesting.
Do we have anything else to add on that? Like, I mean, because I think we just covered it. She and Nos. Well,
We've gone over risk assessment.
Yeah.
Um,
Diverse learners.
Catering.
Yeah, catering for diverse learners, and then how we would assess the activity, just so we have some conversation about that left-hand side too, that she wants in. Yeah.
Well, it's definitely one of those activities you can do in both an outdoor, indoor, actually physical, or you can put it up on ICT. You can use ICT, like you can use one of those online timeline generators or one of those things, and you can actually have little tags on it, or you can make a bit like a mind map situation, and put that over, and you can get ideas, you can take results, you can do a lot of different things with it. And I mean, yeah, like we've got about 3 different ways we can represent it, like we did with the fruit / other materials. We can represent planets. We can actually show pictures of the planets and everything, or we can just number them on a number line. So we've got a bit of the physical, the visual, and the written word pretty much. And we've also got the audible as well, because I mean we can talk about it, or we can have a video play that describes everything.
Yeah.
So if you've got a visual learner, or visually impaired learner, I should say, we've got the audio, and we've got stuff they can actually physically get a hold on.
what about extension students? How do we extend?
I was
students?
just thinking about that.
Do we offer an opportunity for them to look further into gravity and the
Like the purpose of why there are certain width apart, maybe.
possibly
Yeah.
That might be a little bit
Like-
complicated, but sort of on those lines of the spacing between them and how.
Yeah, because there's the section where they're so close to the sun and then they spread out all of a sudden, why? Yeah.
Or explaining the patterns of, because I noticed the pattern of the first 4 planets spin sort of relatively at the same speed. I mean, Mercury spins a lot faster, but then it gets slower as you go down the line. They have shorter, or it gets faster as they go down the line, I think.
Better both. The individual planet spinning gets a bit faster, and then the actual orbit spin
slows
takes.
down.
Yeah.
I know this is a weird question, but do they actually expand in size over a period of time? Are they actually growing an inch or a centimeter, those planets? Is Earth just Earth? It just stays that shape?
Oh.
No.
I think
Because when
I
we
know that the sun is going to changing because it's a star.
Yeah.
Oh yeah, the sun's gonna blow up at one point, but
Yeah.
Because I know with continents, each day or time of the day, I'm not sure, but Australia is slowly chipping away, because you know how we all started as one whole big continent, and you know how we all tectonic plates split away, but eventually we'll all spin back to New Zealand was we've connected to Australia and then it's separated over a long period of time. It's what is Earth? Is it? I don't know. It's interesting.
How we all got to implode back into the sun? You're saying, Kira? We'll all go back.
Yeah.
Mm.
It's interesting.
I like that. That's a good question.
Yeah.
Oh, yeah.
Get some deep understanding into that.
I have read something that Australia does move a certain.
Yeah, close to the sun or something.
Yeah.
I think we look at that a bit next week because we do tectonic plates.
Yeah.
Oh my god.
That'll be interesting.
Yeah, we're jumping ahead.
Jumping
All right,
Yeah.
So that can be the advanced activity for the kids. So prepare them for the next
Yeah.
activity or something like that. Yeah.
how would you assess the activity?
Well, you can't assess students on their guesses. Like that's just
No.
Because it's an introduction to
Yeah.
space sciences, really. So
you could potentially.
anecdotal notes. I don't know.
Could they have to maybe at the end redo one of their scales with the proper answers?
Yeah, so like as if it's maybe an initial versus a final hypothesis of where the planets
Well,
are.
Yeah, well, I think what we did when
Yeah,
we had
we did.
did our first guesses and then we edited and then saw the final. Like I think that's a good progression of knowledge there.
I agree. And then looking at their final product and, you know, making sure it is correct and then I guess
Yeah.
correcting
Yeah.
that if there are any. Yeah.
Just get to make a poster.
That poster.
Yeah.
That's like the lazy way. Just make a poster.
Yeah.
Come on, guys! I got plans this afternoon. Just make a poster. Make a poster.
So
Yeah.
I've just said assess the progression of knowledge by doing a scale of planets at the start and at the end of the learning.
All right. So, have we covered everyone? Not everyone. Have we covered everything? Everyone.
Yeah, I'm pretty sure we have.
My brain's gone.
Yeah, this is a long video.
Yeah, it's gonna take time to process.
All
Yeah,
right.
we need to get on to posting it.
No worries. All right.
Alrighty. Good chat.
Good chat. Catches next time, as they say.
See you next
Stop the recording.
Yeah, I'll stop it. Same time, same place.
Same time, same place.
Hang on. I botched the stopping. Don't worry.